Another user was having issues sintering their impeller design, so I decided to give it a try. I'm printing using Virtual Foundry 17.4 steel filament, and have to shout out to Brad and the team for the flexibility and print quality that this latest spool demonstrated. This impeller was printed with a 0.8mm nozzle at a 0.5mm layer height. The green part turned out great. Let's go ahead and take this down to the workshop to sinter. Summer rains, you can never predict them. Hopefully though, the power will stay on for the kiln. Looking the part over, I think that the best placement will be face down, meaning that the impellers will go down into the ballast. And I'll be using my graphite crucible because I feel like it concentrates the heat a little better than the alumina ones. Also noting that the ballast is mixed with graphite. I make certain to firmly press the part into the ballast. After which I pour another layer of ballast on top. Shaking ensures that the part is supported properly. And then normally I'll tamp down the surface layer ballast to better support. Because I'll be using a lid, I'm only going to use 2 scoops of carbon. The carbon is here for scavenging oxygen so that the part does not oxidize. Also, this will be a single stage debind and sinter, meaning that the debind and sinter stage will be all done during the same kiln cycle. My lid has small holes for the gases to escape. This is my kiln schedule for this fire. Peak temperatures are lower for me due to kiln limitations. Also, I can't overstate the importance of ventilation. After sintering, I waited until the kiln cooled to about 400 degrees Fahrenheit. As you can see, there's sintering carbon remaining, which is a good sign that it did its job to reduce the oxygen in the crucible. Excavating is always my favorite part. The main thing that I'm worried about this sinter is actually not being able to reach the proper temperature with my kiln. But initial results are looking pretty promising. It feels metallic, sounds metallic, and doesn't have any signs of warping after the sinter. The green hue, though, reminds me of some of my previous steel attempts, which really shouldn't be an issue for anyone who has a kiln that can reach the higher temps necessary. In my last tests, these greenish parts didn't quite have the strength necessary to be functional, although they most likely would have all the thermal properties that steel would give. For other users, though, that have kilns that can reach the higher temps required, I'd recommend bumping up by about 200 degrees for the peaks. And for me, I may still be able to get this to work with a longer hold time, so instead of 2 hours, perhaps 4 hours. Anyways, thanks for watching, cheers, best of luck with your metal projects.